Digital Switching System. Module 2. In this video lecture we will cover the topic on message switching and circuit switching. Switching systems and associated signaling systems are essential to the operation of telecommunication networks. The functions performed by the switching system, or a subsystem of it, in order to provide customers with services are called facilities. In this module we are studying about historical approach of the switching system. Now let's discuss message switching. In early days of telegraphy, a customer might wish to send a message from town A to town B. Although there was no telegraph circuit between A and B, however, if there are a circuit between A and C and one between C and B, this could be achieved by the process known as message switching. Messaging switching is better known as the stored and forward approach for an entire message. In a message switching center, an incoming message is not lost when the required outgoing route is busy. It is stored in a queue with any other messages for the same route and retransmitted when the required circuit becomes free. Message switching is thus an example of a delay system or a queuing system. Now let us discuss different kinds of message switching that has developed over the years. The operator at A sent the message to C, where it was written down by the receiving operator. This operator recognized the address of the message as being at B and then transmitted over the circuit to B. This manual process is shown in Figure A. Subsequently, technical developments enabled improvements to be made in message switching. First, the message received at C was automatically recorded on punched tape and subsequently torn off the receiver by the operator, who read the address from the tape. The message was then retransmitted automatically from the tape, as shown in Figure B. This was known as torn tape relay system. Later, the outgoing route was also selected automatically, as shown in Figure C. Finally, the paper tape was eliminated by storing the messages electronically and analyzing their addresses by electronic logic, as shown in Figure D. A modern messaging sender is thus a special-purpose electronic computer. In fact, message switching was first area in telecommunication to adopt stored program control (SPC). Message switching is still used for telegraph traffic, and a modified form of it, known as packet switching, is used extensively for data communications. The Visual Display Unit (VDU) operator will not obtain the desired quick response to a message if it has to wait for the completion of a large file transfer. This problem is solved by dividing long messages into smaller units, known as packets. A packet switch sends each of these as a separate message. Thus, packets of different messages are interleaved on an outgoing circuit, and a short message doesn't wait for the transmission of a long message to be completed. Now let us discuss circuit switching. Circuit switching allows two-way communication in real time. In circuit switching system connects the circuit of calling telephone to that of the called telephone on demand, and it maintain this connection for the duration of the call. Here, if the required outgoing circuit from a switch is already engaged on another call, the new call offered to it cannot be connected. The call cannot be stored, it is lost. Finally, let us discuss functions of switching systems. The basic functions that all switching system must perform are as follows. 1. Attending. The system must be continually monitoring all lines to detect call requests. 2. Information receiving. In addition to receiving call and clear signals, the system must receive information from the caller as to the called line required. This is called the address signal. 3. Information processing. The system must process the information received, in order to determine the actions to be performed and to control these actions. Since both originating and terminating calls are handled differently for different customers, class of service information has to be processed in addition to the address information. 4. Busy testing. After processing the received information to determine the required outgoing circuit, the system must make a busy test to determine whether it is free or already engaged on another call. 5. Interconnection. For a call between two customers, 3 connections are made in the following sequence. A. A connection to the calling terminal. B. A connection to the called terminal. C. A connection between the two terminals, calling terminal and called terminal. In the manual exchange system, connections A and B are made at the two ends of the cord circuit, and connections C joins them together in the cord circuit. Many automatic systems also complete connections C by joining A and B at the transmission bridge. Modern systems release the connections A and B and establish connection C over a separate path through the switching network. This is known as callback or crankback. The calling line is called back and the connection to the called line is cranked back to it. 6. Alerting. Having made the connection, the system sends a signal to alter the called customer to the call, for example by sending ringing customer's telephone. 7. Supervision. After the called terminal has answered, the system continues to monitor the connection in order to be able to clear it down when the call has ended. When a charge for the call is made by metering, the supervisory circuit sends pulses over the P wire to operate a meter in the line circuit of the calling customer. This process is known as calling line identification. 8. Information sending. If the called customer's line is located on another exchange, the additional function of information sending is required. The originating exchange must signal the required address to the terminating exchange.